Welcome everyone. In this video, I am going to discuss about three important but simple indefinite integrals and their applications. Look, integration, first one is integration sin to the power nx cos to the power mx dx. Cos to the power mx dx. If m plus n equals to even negative integer, then put tan x equals to z or cot x equals to z. Or you may consider this in this form also, dx by sin to the power nx cos to the power mx. So here m plus n equals to even positive integer, because look here, this n at the denominator. So same transformation, tan x equals to z, cot x equals to z. So first look, dx by general method sin to the power mx cos to the power nx. If m plus n equals to even, we have to put tan x equals to z or cot x equals to z. So our main aim will be to get here tan or cot. So sin to the power mx cos to the power mx, and this is cos to the power m plus n x. So it is balanced. So numerator is sec to the power m plus n x dx by tan to the power mx. Now if we put tan x equals to z, so tan x equals to z. So sec square x dx equals to dz. Now since m plus n is even, we can express it in this form. So 1 sec square x as it is, and this is sec to the power m plus n minus 2x, and this is tan x. So expressing this sec, since this one is even, we can express it in terms of tan, then putting value of tan x in terms of z, we get standard integral. So let us discuss this rule with an example. So its application. So look, problem number A, application. So dx by sin to the power cos cube x into 2 sin 2x. Look, this one. So dx by cos cube x and 2 sin x cos x. Sin 2x equals to, so 2 outside, sin to the power half x cos to the power half x. So finally what you are getting, half outside, cos to the power 7 by 2x sin to the power half x dx. Now look, cos to the power 3 plus half, 7 by 2, this. So if we consider alternative one, so m plus n equals to 4, even positive integer. And if we take it at the numerator, minus 7 by 2 minus half, so minus 4, even negative integer. So rule is tan x equals to z or cot x equals to z. If power of cos is greater than sin, so if we put cot x equals to z, it will be simple. So cot x equals to z. So derivative, so cosec square x dx equals to minus dz. Now our main aim will be to express it in terms of cot. So dx by cos to the power 7 by 2x sin to the power 7 by 2x, and sin to the power 7 and sin to the power half. This is sin to the power 4x. Sin to the power 4x. Now look, this one is cosec to the power, so cosec square x, and 1 cosec square is 1 plus cot square x by cot to the power 7 by 2 x dx. Now put value of cot x equals to z. So 1 plus z square into minus dz by z to the power 7 by 2. So if power of cos is greater than sine, we put cot x equals to z. So minus z to the power minus 7 by 2 dx plus 2 minus 7 by 2. So z to the power minus 3 by 2 dx. So now this is in standard form. Integrating, we get result. So this one is minus z to the power minus 7 by 2 plus 1 minus 7 by 2 plus 1. This is also minus 3 by 2 plus 1 minus 3 by 2 plus 1 plus 6. And putting value of z, we get this. So look, if we know the rule, then we can put the particular substitution. Otherwise, we have to use trial and error method. Now look, one more problem. So look, C sec to the power 8 by 9 cosec to the power 10 by 9 D exactly same. So this is problem of JEE Main of 2020. Now look how simple it is. So consider problem number C. So sec to the power 8 by 9x into cosec to the power cosec to the power 10 by 9x dx. So we know rule in terms of sine and cos. So this is dx by cos to the power 8 by 9x into sine to the power 10 by 9x. Now look, what is m plus n? M plus n minus 8 by 9. If we consider 1, so m plus n minus 8 by 9 minus 10 by 9 minus 2. So this is even negative integer. So we put tan x equals to z. Tan x equals to z or cos x equals to z. Cot x. So sec square x dx equals to dz. Now look, so we have to express this sine in terms of tan. So this step to be noted. Sine to the power 10 by 9x by cos to the power 10 by 9x. So cos to the power 8 by 9x into cos to the power 10 by 9x. So it is balanced. So now this is sec square x. So this one is very simple problem. So cos square, so sec square x, and this is tan to the power 10 by 9x dx. So what we are getting? We are getting dz by z to the power 10 by 9 dz by z to the power 10 by 9. So finally this one is z to the power minus 10 by 9 dz. So this is standard formula, minus 10 by 9 plus 1. So minus 10 by 9 plus 1 plus 6. So putting value of z, we get primitive, that is solution. So look this rule. So application, if m plus n is even negative integer, put tan x equals to z or cot x equals to z. Now we consider second integrand. Look, e to the power x fx plus f dash x dx equals to e to the power x into fx plus. So we can integrate it by putting substitution or integrating it by parts. So look, if we want to integrate it by substitution, so possible substitution is e to the power x into fx equals to z. So let this equals to z. Now look, by product rule, e to the power x into fx, e to the power x into f dash x, dz by dx. So what is dz? E to the power x fx f dash x dx. So the integral reduces to, look, dz. So this is z plus c. Z plus c. What is z? E to the power x into fx plus c. So e to the power x, the function plus its derivative. Then answer is e to the power x into fx. So this is most important integrand. So this is very simple. So look, applications. So these are very simple problem of board exam also. But the simple problems will also come to competitive exam also. Look, first one, e to the power x, x by 1 plus x whole square. E to the power x, this, e to the power x. So 6 problems. So these are simple problems. So look, so we consider problem number 1. So e to the power x, x by 1 plus x whole square dx. Now look, we can use above rule if it is of the form e to the power x, fx plus f dash x. So this is not given directly. So you express the numerator in terms of denominator. Denominator is this. So this is 1 plus x minus 1 dx. Now e to the power x, 1 by 1 plus x minus 1 by 1 plus x whole square dx. Now look, so 1 by 1 plus x, if we consider this as fx, then its derivative is this one. So what is the answer? Answer is, we can write answer directly, e to the power x, 1 by 1 plus x plus c. So what is the transformation? If it is broad problem, you write this step and differentiate. So otherwise it is in standard form. So e to the power x into fx. Now second one also same problem. So x square plus 1. So you have to express, you look one step. Denominator is x plus 1 whole square. So this can be written as x plus 1 whole square minus 2x. So e to the power x, 2 part. So this and this cancel out. 2x by x plus 1 whole square dx. Now derivative of 1 is not this one. Also derivative of this not 1. So we cannot apply this theory directly. So write it 2 parts. So e to the power x dx minus 2 outside x e to the power x by 1 plus x whole square dx. Now this is of 1. You can easily integrate it. So this one is 2. Now third one. So this is not given in standard form. This is not in standard form. Here base of log is obviously e. In mathematics, ln, obviously it is given or not. Ln means base is e. And in mathematics, if base is not mentioned, we suppose that base is e. So look, problem number 3. Put log x equals to z. Base is e. So what is x? E to the power z. So dx equals to e to the power z dz. So now problem number 3. So this is sin z and this is cos z. So what is dx? E to the power z dz. Now this is of standard form. So derivative of sin x. So e to the power z sin z plus c. What is z? E to the power log x sin log x plus c. And e to the power log x is x. X sin log x plus c. Now 4 and 5. Look, this is your home task. Look, 4. Derivative of x to the power 5 is 5x to the power 4. So we write it as a sum. E to the power x, x to the power 5 plus 5x square plus e to the power x separate. Now this is your home task. Now problem number 6. So look, it is not given in standard form. Problem number 6. So look it again. So this should be z, not tan inverse x. So transformation is tan inverse x equals to z. So what is your transformation? Tan inverse x equals to z. So what is x? So x equals to tan theta, x equals to tan theta, dx equals to sec square theta d theta. Now this one reduces to e to the power z 1 plus tan theta plus tan square theta by 1 plus tan square theta. 1 plus x plus tan square theta, 1 plus tan square theta, and dx is, what is dx? Sec square theta d theta. Now finally 1 plus tan square theta, it is actually, look, not sufficient space, so you write from left, e to the power z, then 1 plus tan theta plus tan square theta by 1 plus tan square theta. Now what is sec square theta d theta? This cancel. So it is z or theta. So look, this one is, suppose tan inverse x equals to theta. So e to the power theta. So e to the power theta, this cancel. So tan theta plus sec square theta d theta. Derivative of tan theta is sec square theta. So finally we are getting e to the power theta into tan theta. Putting value of tan theta, we get primitive. So these are all very simple of both level. Now look, 7, 8, 9, they are given in twisted form but very simple. E to the power tan theta log sin theta plus cosec square theta into cos theta d theta. Log of log x plus 1 by log x whole square, e to the power x 2 minus x square 1 minus x into root over 1 minus x square ds. Now, so what is our main aim? To put it standard form, e to the power. So obvious transformation is, so this is, so e to the power, sorry, this one is sin theta. So correct it, e to the power sin theta. Sin theta, derivative of sin theta is cos theta. So obvious transformation, sin theta equals to z. So cos theta d theta equals to dz. Now look, this reduces to e to the power z, then log z plus 1 by z square. Log z plus 1 by z square. Now derivative of log z is not, is 1 by z, but it is given in 1 by z square form. So look, we use this log z, so derivative 1 by z. So make it balance by 1 by z, 1 by z square dz. Now look, this is log z plus 1 by z, standard form. Log z, derivative of log z is 1 by z. Then integration, if we take minus common, 1 by z minus 1 by z square dz. So derivative of this is, so e to the power z into log z, and this is e to the power z into 1 by z plus 3. So putting value of z, we get primitive, that is solution. Now this one is exactly same. If you put log x equals to z, then it reduces to the earlier one. So dx equals to e to the power z dz, this is log z 1 by z square. So 7 and 8 exactly same. So last problem number 9. So here e to the power x is given, e to the power x. So look, e to the power x, 2 minus, denominator is 1 minus x square. So we can write it in this form. So 1 minus x into root over 1 minus x square dx. Now look, this one is e to the power x, 1 minus x square, 1 minus x into root over 1 minus x square plus 1 by 1 minus x into root under this. So e to the power x, then bracket 1 minus x is cancelled, so it will be 1 plus x. So 1 plus x, this is 1 plus x, and this is root over 1 minus x square. So 1 by 1 minus x, this one is unchanged. So finally e to the power x 1 plus x by 1 minus x, total root. So this one is 1 minus x root under 1 minus x square dx. Now look, problem will be solved if we consider this as fx, if its derivative is second one. So let us verify what is its derivative. So 1 plus x by 1 minus x root over. If we consider this as u, so its derivative, so derivative du dx, half of, power is half, 1 plus x 1 minus x whole to the power minus half into ddx of 1 plus x 1 minus x. Now this one is half of, this is 1 minus x by 1 plus x whole to the power minus half at the denominator. So 1 minus x whole square. So 1 minus x unchanged into 1. 1 plus x into minus 1. So half of root over 1 minus x 1 plus x. 1 minus x whole square. Now this is 1 minus x plus 1. So this is 2. So 1 minus x. 1 minus x, this is plus 1, this is 2. So 2 cancel. So finally what you are getting, you look, 2 cancel. So root 1 minus x, 1 plus x, root over. This is 1 minus x into root over 1 minus x into root over 1 minus x. So 1 minus x cancel out. Now we are getting 1 minus x and this one is 1 minus x square. So derivative of this one is this. So what is the final result? E to the power x, this one plus c. So this one, e to the power x, fx plus f dash x dx. So e to the power x, fx plus c. So now we consider integrand number 3. Now integral number 3. So a to the power x, a to the power x, a to the power x, a to the power x dx. This is basic problem of integration of first chapter. But this problem, so very often will come to West Bengal joint entrance examination. Now this one, a to the power this. So what is the answer? So answer is, look, power if, then second one is this. So answer is first one, how many times a occurring? So log a whole to the power 3 base is e. Now e. So how many times? 3. So first one is answer by log e. Log e is 1. So log e 1. That is why this one is absent. So if it is 2 times, 5 to the power x. Log 5 whole square. So you know how to prove it. So if you want to prove this result, then what is our transformation? So a to the power x equals to z. So derivative of this into ddx of a to the power x. So dz by dx into log a dz by dx. Now a, this one is unchanged. Derivative of this a to the power x unchanged, then ddx of a to the power x into log a, and previously 1 log a is given, so log a whole square, and a to the power x, a to the power x. So a to the power x log a, that is whole cube, equals to dz by dx. So what we are getting? Look, a to the power x, a to the power x dx. So dz by log a whole cube. So first integral reduces to, what is this? This one is 1 by log a whole cube into dz. So 1 by log a whole cube into z. Now what is z? z is a to the power x plus c. So this is problem of first chapter. So answer is this one, first one, by how many? 3a. So log a whole cube, log a whole cube. So in this class we have discussed three important integrand and their application. They are very simple problem. They are very simple problem, but important too for competition also. So you solve the rest of the problems. Thank you.